differences between, we're still an introduction to Node. So differences between Node and the browser. So you have to realize that there's this difference, right? And you'll notice some of the things we focused on in full stack 2, which is why we spent a lot of time. So while you're learning to code, you can be confused at where does JavaScript end and where does Node.js begin, and vice versa. It's true. You're going to be thinking, you may get caught up in coding Node.js and be like, wait a second, that doesn't make sense. It doesn't exist in JavaScript. That's because you have to remember that we are using kind of a wrapper of JavaScript. We're still using JavaScript, but we got to remember we have access to all those built-in modules, like file system, that we don't have in the browser. This is only specific to Node.js. So it's you can get confused a little bit, right? If you just do server-side JavaScript and then you jump back onto the web, you just have to keep grasp of where you are, right? But you'll still be using JavaScript. So a good grasp of these main concepts are required before Node.js. So we tried to focus on a lot of these: lexical structure, right? Lexical scope, using let variables and var and those keywords, expressions, types, variables, functions. This concept, arrow functions, loops, scope, array, template, literals, semicolon, ES6. So you can see we covered all that. That's why we did so much. We didn't cover strict mode. I'll have to remember to do a slide on that. And we didn't really look at the other versions of ES 2017. Again, those are just different. There's a couple more features, but it's not as big as a published release as ES6. Again, if you look at the spec, you'll just see a couple things are added per release. And again, if you want Node.js to take advantage of some of those more advanced concepts, you can reconfigure your environment to make it work in that way. Right, so some main concepts that we need, some main JavaScript concepts that we touched on. Some of them, we're going to get into some of them as well. They're more intermediate stuff, but we really deal with async programming. So we touched on async a little bit with promises, but Node.js is event-driven. It's very asynchronous, which is really powerful. So we need to know about asynchronous programming callbacks. We are going to be doing callbacks like no tomorrow, right? Timers, we're going to be using timers a lot. We'll get very familiar with those things. Promises, we had a good prep for that. Async await, we haven't used that. That's like the next step up from promises, right? We haven't touched closures, but I mean, we certainly will. Event loop is the big one. The event loop is the main core architecture of that drives Node.js to make it asynchronous, and we have a whole chapter on event loop. So some pros and cons to Node.js. Somebody else speak on it, but yes, there's a lot of there's some pros and cons. Hopefully you can hear the audio.
Everyone's familiar with JavaScript, the most popular programming language, used as a client-side development tool in 95% of websites. But what about the server-side programming? Well, with the introduction of Node.js, JavaScript has become an all-purpose, full-stack development language. So let's discuss what Node.js is and then explore its advantages and disadvantages. Node.js is an open-source runtime environment for JavaScript. It's based on Chrome V8, an engine for Chromium browsers. Node.js allows your programs written in JavaScript to be executed on the server. First written in 2009 to create dynamic web pages before they're sent to a browser.
Anyway, can you guys hear me? Raise your hands. Yes? Okay, great.
It soon became one of the most used tools in back-end web development. Node is a part of popular Mean and Mern, JavaScript-centered technology stacks that cover the entire web development pipeline. There are many frameworks built for Node, including such popular ones like Express.js, Meteor, Sails, and others. To source modules and ready-made packages, you can use NPM, an extensive package base that helps build with Mean and Mern stacks. So there are multiple reasons why Node.js became a standard for enterprise companies like Netflix, Uber, and eBay. To determine whether Node.js fits your needs, let's look first at its pros and then we'll consider the cons. We'll begin with the strengths. Node.js has opened the doors to JavaScript full-stack development, inheriting the merits of JavaScript programming as well as allowing engineers to use its libraries and features. Lightweight JavaScript achieves high performance with fewer lines of code when compared to Java or C. Also, the front end and back end are easier to keep in sync because of a single language used on both sides of the application. Developer-wise, it also became possible to share and reuse code. With the help of Node modules, which are basically independent chunks of code, developers can use pre-built modules or reuse their own. Node.js is highly scalable and lightweight. That's why it's a heavy favorite for microservice architectures. In a nutshell, microservice architecture means breaking down the application into isolated and independent services. It makes it easier to update and maintain the architecture as your services are decoupled, and you can add new or fix existing architecture without dealing with other parts of the application. Node.js fits well for designing such architectures with the help of Node modules, which represent building blocks of Node.js functions. Node.js is considered fast thanks mostly to Chrome's V8 engine. It's used to compile JavaScript into machine code instead of using an interpreter. JavaScript community notes constant improvements in the engine as Google continues to invest heavily in it. While its event-based nature makes Node.js highly efficient for real-time apps that require constant data updates, the non-blocking input-output model solves performance issues. The performance is enhanced by concurrent request processing, which uses a single-thread event loop. A non-blocking input-output model allows for processing several requests at a time. This makes Node.js highly efficient for processing multiple requests with less CPU usage. In 2015, a number of companies, including IBM, Microsoft, PayPal, Fidelity, and SAP, organized a Node.js Foundation. It's an independent community aimed at facilitating the development of Node.js core tools. Regardless of active corporate involvement, Node.js is an open-source project that gathered a vast community of developers providing ready-made solutions and guides for each issue on GitHub. With a growing community, you'll always have pathways to the solutions of your specific problems. Few programming languages can boast such a rich package ecosystem as Node.js. Thousands of libraries and tools for JavaScript development are gathered on NPM, a default Node.js package manager and marketplace. With the constant support of the Node.js community, NPM focuses on encouraging users to add new packages, so you have countless ready-made solutions for specific issues. Since Node.js inherits many JavaScript features, including its libraries, front-end developers will likely learn it pretty quick. Also, considering the community support and the overall popularity, JavaScript has a fast learning curve for beginner developers. But all that said, Node.js is not a silver bullet. It also has drawbacks that you want to keep in mind. As we mentioned, Node.js uses a non-blocking input-output model for processing requests, so it's considered single-threaded by nature. Node.js is capable of processing several simple tasks, for instance, read database query, without blocking the main thread. Whenever there is a heavy computation request, Node.js would set up a block on other requests on the thread, causing an overall delay. And that's considered a major drawback. In the latest updates, threading was introduced as an experimental feature designed to process heavy computations. Using a worker thread module, developers are now able to spawn additional threads for parallel processing to carry requests that block the event loop. Considering this, Node.js may become suitable for processing CPU-bound tasks and used for machine learning-based calculations in the near future. NPM registry seems to be quantity, not quality-driven. While core products prove to be stable and well-tested, the rest of the NPM registry is poorly structured and badly documented. Of course, that's not uncommon for open-source projects. The last point worth mentioning is the lack of experienced JavaScript developers that work with backend. While JavaScript developers are the major group on the market, statistics show that a typical Node.js developer has 2 years of experience with Node half of their working time. Wrapping up, Node.js is a powerful and lightweight tool for full-stack web development. Most likely you would use it when building microservice architectures or even cross-platform desktop programs with an Electron framework. As with any tool, it has its weaknesses, like performance bottleneck for CPU-heavy operations. But the project is strongly supported by the community, and enterprise giants are investing in its development. So when choosing a backend tool and comparing such options as Python-based Django, PHP Symfony, or Ruby on Rails, also consider Node.js.
Interesting. I gotta say. I didn't realize the backing, the corporate backing they got from Microsoft and IBM. Interesting. I didn't know that. So they are getting involved. But yeah, you know what? The good they mentioned the cons. The scalability is pretty nice, pretty sweet. When you see the scalability, how you can get around that, it's pretty nice. Yes, the NPM registry, you know, you have to be aware. We'll get to that in when we talk about that. But yeah, I mean, microservices and those kind of things. I mean, I come from a .NET background, so for me, server-side coding is where I feel most comfortable. Feel pretty good at JavaScript, but you know, just the amount of time I can easily switch to Node.js easier than you know, front end full, you know, just 100% front end. I can do it for sure. It's just I'm probably much better suited to be server-side JavaScript than probably front-end JavaScript because you know, you basically get rid of you don't have a UI sometimes. You're just dealing with logic and computation, right? But anyhow, you need to just remember that we are not dealing with the browser anymore at this level. When we do the full stack, when you need to do, say, your project for you know, any task, we will have to hook up an interface, right? But we need to know how to build a server and provide data, and then you can you know, whether it be React or Angular or a mobile device. Those are the types of interfaces that could call a backend, or it could be another service, another web service calling a web service. It doesn't necessarily have to be an interface. It can be, it certainly doesn't have to be a browser. You can field requests from anywhere, server to server, using those different protocols we'll get into when we talk about web servers. But right, so both the browser and Node use JavaScript. We established that. When we build those apps that run in the browser, it's very different, right, than this server-side coding. You know, we know that there's some key differences in that to make it radically different. Well, for instance, we don't have access to the DOM and the BOM, the document object model, and the BOM, the browser object model, like the window doesn't exist here. The window, if you try to run Node, the window, it doesn't know what you're talking about because the browser is not there. Just remember that. So from the front end perspective, developer who uses JavaScript extensively, Node.js apps bring that advantage back to them, that comfort level, that everything is in a single language, front end and back end. So we switch in between. Oh, sorry. moving ahead, but what changes is the ecosystem, right? So when we have a different ecosystem, no longer we're dealing with interacting with the DOM or the web platform APIs and the browser, like cookies, local storage, and those kind of things. They don't exist here. They don't exist in Node.js. So you don't have the document, the window, those other objects by the browser. We are now focusing specifically on the Node.js objects and globals, and they have their own set that we need to learn. Like in the browser, we don't have all of the nice APIs, but Node provides a lot in its built-in modules, like the file system I talked about. They have a lot of global built-in objects we'll talk about. They even have their own version of the console. So you can do simple things like console log. Again, it's not the true console log from the browser, but it's basically a replica of it. So we have those. Plus, whatever else we may need, we can go and leverage that NPM registry and grab some additional built-in modules whenever we need to. So another big difference is that you control the environment. So like I said before, if you are really good at configuring servers, you don't have to be, but if you are, you can build your own, you can build and configure your own environment, add your own packages. You can also, unless you're building an open source application that anyone can deploy anywhere, you know which version of Node.js will be running, so you can configure and control the versioning based on your environment, which is another big thing. You may have a server that, so you may have so this is, we get into packages and semantic versioning. You control the version because you may deploy somewhere. Say you're deploying to the cloud. The cloud may have a certain version of Node.js. Certain versions of packages only work on that runtime, which could be much different than your development environment, because your development, and this is the trick, your development environment could be, could be configured, highly configured. The latest Node.js, the latest everything. The server, the production server, might not handle that. So you have basically a control in place to control the minimum version, so that when your piece of code gets deployed, basically the minimum version for all of those packages can be maintained, so nobody can update them, breaking your code. Like there's a way to control that with package.json, those kind of things. So compared to the browser environment, you don't get the luxury to choose what browser your visitor use, right? You don't get to choose that, but you can write. So you can write ES 6, 7, 8, 9 JavaScript if you want. But you got to remember you have to upgrade your version of Node.js to support those, right? Maybe my Node.js version 13 or whatever I'm on, it might only run ES6. However, I found sometimes when I upgrade to the latest, sometimes other packages break. I'm trying to think of one right now. I think last time I upgraded my Node.js, last time I was doing full stack, I think create React? Something when I was working in React broke, and then I think I was trying to use virtual React VR, which is virtual reality with React, and it broke for some reason, so I had to downgrade back to Node 13.1, and that one worked, and I could demo that. So you can control the versioning and downgrade, upgrade, but you just have to remember that not everything's going to play nicely all the time, and you get into that configuration stuff. So JavaScript moves fast, browsers move slow, but on the web you're stuck with those older versions of JavaScript and the browser. But we can configure our own we can configure our own upgrades here if we need to, but just keep in mind, not everything will be compatible, right? So if you are going down this path, again, it's not required. You could use Babel. You could use Babel to transform your ES5 compatible code before shipping it to the browser. You could do that on the web, but in Node.js, you don't need to do that, right? So another difference is Node.js is it uses this common JS module. So we have modules. So when we learn require and modules and things like that, we can leverage these modules much like you could use classes. The browser, we are starting to see these ES modules being implemented. So we haven't learned modules yet, but it's newer ES syntax. We're going to be all over modules because Node.js is based on this. So we're going to be using require a lot. The equivalent to require in the browser would be import, but we never really used import too much because we didn't actually learn modules yet. But we're gonna be all over modules very shortly. Again, it's just a way of it's basically, if you download a module, you download a package, it's considered a module, and you can import it using require. So you can basically take that module and import it into your script, and then suppose you have a moment module, you could bring it into that, and then basically you set it up as a variable, and you have access to all those built-in features. You have it just by using that require keyword. It's pretty nice. Again, we're going to be using the command line quite a bit, so you need to become familiar and comfortable in the command line setting. As we established already, you're going to run the Node script from the command line. So usual way to run this is Node is globally available. So once you install it, like we said, when you have it installed on the command line, when we are there, when I run Node here, should give me back that it's version 12. It's global to my environment. It knows now I'm in the Node module. I'm in this Node this interpreter, right? Again, I can do Control-C to get out. So basically, we need to become familiar with this. If we want to run a script, we need to set up our project. To be honest, we haven't done that yet, but we need to become very familiar with this. If you need to exit it, just so you know, because some people get stuck in that loop. Full stack 3 students, usually I used to let them write all those ES6 from the start. They would write ES6 JavaScript, all those like function questions I used to give you. I had them write them in Node, and I had them just basically write them inside of inside of here, and then they would run them on the command line using the Node command. I'll show you in a second. One problem with that is that you'll notice you have to keep Control-C and exiting and starting again and stopping again. It's really painful. There's a great tool that I give you guys right away at the end of your lab called Node Monitor, which basically when you kick it off, it'll run and monitor any changes in your code. So you don't have to, anytime you click save, it'll recompile and output the changes. So you don't need to keep canceling and building. You just run that thing, make your code changes, it'll automatically pick up the change and compile it for you in real time. Super nice. I'll give it to you right away. Normally I let them kind of struggle a little bit with that one, right? So let me just quickly, I had these examples ready, but I'll let myself demo for you again. Once you get inside the terminal window, if you can actually run Node with -v, which is version, and you actually get something back, you know that Node is installed. So basically, Node, from what I can tell here, is running version 12.13.1. So I know that it is actually there for me, and I can actually interact with the shell. So if I were to actually just do something like this, Node, welcome to Node.js. Now I have the prompts. I could actually run something against it, some JavaScript against it. If I just went 5 + 5, 15, should equal 20. All right. Var A equals 5. What does that do? Some JavaScript undefined. All right. Var equals 5. Console log A. Right. I get 5 back undefined. Okay. If I were to actually do some JavaScript here, x equals an arrow function, console log dot hello, right? And I run that, will happen undefined. Okay, so if I actually have this, and then I actually call it, throw a syntax, and x has already been declared. Oh, the joys of live programming, right? All right, what's happening here? So if I declare it once, if I actually call it, there you go. See, I was trying to declare it on the same line. When I had actually declared it in the runtime, it actually existed, and I was able to then call it as a variable. So that makes sense to me now, right? It's actually running in the shell, and I'm interacting with the shell. Yeah, you're writing code against the command line, which is not really the greatest, to be honest. So if you wanted to exit out of this, you would go Control C and you get out of the shell. Let's press it again, and I'm out of that shell. Okay, so that's Node. I mean, now it says that we have that runtime and we can actually work with it, but we want to verify that we have npm installed, right? So npm, same thing, npm version -v. I'm at 6. We're gonna get to npm. We're gonna get to npm pretty soon, but yeah. So that was setting it up. So if we wanted to so if we wanted to create a script, right, we'll just create a hello world script, hello.js, right? Inside of this script now, we can just we could try to create something, right? I don't know. Something as simple as, what am I gonna say? I don't know. Say hello. Equals to a function. I'll start off small like this. And I just want to console log, console log. If you notice now, I'm actually, like, it's the same syntax as if I am, now let's try to run it though, right? So I have this function here, and I'll invoke it inside of the script. So just picture this as the script that's referenced inside your browser. You're invoking it right away. However, I have no browser to invoke it, so I need to use Node to compile that JavaScript and run it, right? It needs to compile it down. It needs to compile it down to machine level code and instructions, and basically interpret this syntax, because this is just syntax for me. Remember, I'm not in a browser. So if you're using the command line, I don't know what command line you prefer. Sometimes I prefer this one. I don't know why, but it's kind of old school. Again, you can change your appearance of this. I have a theme installed. That's why my Visual Studio looks this way. You might want my Visual Studio Code. You might want an all white interface if you don't like this black. It's too drab. Perfectly fine. But I'm on Windows command. I'm used to it. So if I go dir, which is directory, it'll give me a list of what's in my directory, whether it be folders or not. I just have this sitting in the main root folder here. So I would need to run this. I need to use the Node shell. I need to use Node to run this script and compile it, down and execute. So hello.js. So it outputted this hello. So hello Node.js, right? I'll just save that. If you notice, I made a change here, and it does autosave, or I do need to do Control S, right? Then what I need to do again, I need to type node hello.js again. Okay, so now I'm executing out of the shell here. Okay, now I need to do another console log. You can see already it's a little tedious, right? Like I had to keep compiling all the time, right? Hello again. Any change I make, then I have to go back here and I need to again node hello. It gets very tedious, right? So when we get in your lab, you'll see you use npm to install something called node monitor, which basically I'll show you in a bit. But when you kick it off, it'll monitor, and anytime I do a change, it'll basically recompile all of this, and then it will output the new response. And then anytime I'm working, it'll recompile as I'm working in real time. Saves you a lot of problems, right? A lot of headaches, right? So let's see if I can do some ES syntax with const. Well, is that going to bark at me, right? With my version of Node, hello. Again, I got a hello dot. So that's fine. Let's see if I can do arrow functions with the current version I got. So it should be good. Should be all good. All good. If I want to use template literals, right, with the syntax, should be all good. So I know that I know my version of Node can support some of these newer syntaxes, right? Maybe not all of them, but most of them. Okay, so that's all good. So, right, so I'm interacting with the shell, which is running my script, which is compiling my JavaScript into machine level instructions, which then my compiler can run and execute. But from the developer's point of view, hey, I'm just doing JavaScript, so I don't know what's happening. I'm just doing what I know, but there's a lot going on behind the scenes to make you feel at that comfort level, right? So you need to understand that, and you're going to be using Visual Studio Code quite a bit. In fact, you know, you might try to play with this. There is a way to start with debugging. Let's try to see this. Run start debugging. So you could actually set some breakpoints in here, right? And you could run start debugging, and I would say pick Node. I believe it's Node.js preview. Experiment with those. Don't launch Chrome. Don't launch Edge, and don't launch this other one. Let's try Node.js. See. So you can see now. Oh, I'm going into some. Why is this happening? Allow access. Okay, doesn't matter. I'll allow it. I don't know why that's doing that. Oh, it's gonna. Okay, anyhow, you can see now I have this debugger firing now, right? So I have this console here, which is similar to the browser. And you can see I stopped at my breakpoint, and I can skip over or use F10. I'll just use the click, so I can step through, right? It's been outputted, but I'm basically stopping execution. So you can imagine you could run your debugger and step through your code. I don't know, you probably never used this before. You probably used the browser, but now we're running server code, so we can step through everything. So it stopped. So basically I hit a breakpoint. I could inspect values if they were there. Otherwise, you know, if I skip over this, it finishes execution and exits, right? If I say, you know, I have a sum where I have 5 plus 10 equals to 14. No, equals to 15, right? Sum. So if I start my debugger again, I'm going to try to pick the other one because I didn't like that thing popping up. Let's see. Start with the preview. So it shouldn't. All right, so it basically I don't get that firewall. So yeah, as you're stepping through the code with F10, you know, as I get to this expression, same thing. Now I can evaluate what that variable is by hovering over top. So I don't always have to console log. So this is very handy when you get into some very complicated logic, right? You can start to inspect. So you don't always have to console log everything, but if you wanted to, it'd be fine too, right? And that console logs that. Execution is still inside of this script, and then I exit out. But if you notice here, it looks like I'm still in debugging here. Something's happening. It didn't return the shell, so I'm going to try to see Control C or Control X. What's happening here? It seems that I'm locked inside of my debugging tool. Please start a debugging session to evaluate. So somehow I'm locked inside my debugger. Well, that's not good. So I guess it's waiting for me to start debugging again. Right. Oh, I'm sorry. I'm sorry. If you notice here, when I went in debugging mode, it switched the terminal on me. See, this is my terminal. It switched to this debugging console automatically. So now I'm in debugging mode, and it's just outputting inside of that console. So I do have control, sorry. So it ended in this debugging console. That was all the result from my file, as you can see over here. I don't know why it's all the way over here, but you can see hello.js. It'll give you a stack trace. If I want to go back to the main terminal window, I click this tab and I'm back. I have control still. If there are any problems, I guess it would be here. Any output would be there, I guess, for compiling, but really the debug console and the terminal window. And again, you can use multiple terminal windows inside of your Node.js. Why would you want to use multiple windows? Well, for example, you might have different processes running. You may have, especially like in full stack 4, you could have Node.js server running on this terminal window, and you could have a React server running on this terminal window, and you would have to talk to each other, but they're both spawned on different ports, and you may need to just kick both of them off in this way, right? So anyhow, Yeah, so we definitely run it differently. Those are a lot of differences, right? We're not using the browser, we're not using the browser console. So we need to become very familiar with all that. So let's get a little bit another insight. I won't play the whole thing, but this guy has, I think, some other good tips here on it. I'll play like half of it.
Everyone's familiar with JavaScript, the most popular programming language, used as a client-side development tool in 95% of websites. But what about the server-side programming? Well, with the introduction of Node.js, JavaScript has become an all-purpose.
Actually, we did that one already, didn't we? Okay, so I think I had another one. I guess I missed it then somewhere. It was another good one, but I'll if I don't find it, I'll post it. Yeah, there was another better one than that. Sorry about that. But anyhow, let me stop recording on that section there. That was on the differences of Node.js and the browser.